Hey, I'm Joe Burnett on the Runner team. I want to show you a proof of concept that I built out. This is a little demo that is going to run a job in a Kubernetes cluster, but it's going to do it in an unusual way. So I'm going to show you, just going to show you the thing running, and then I'm going to unpack it a little bit and show you the code path that we took and what it is that's interesting about this to me. Um, so for starters, here's my little hello runner project, right? It has an image, has a couple of steps. Notice these are native steps, so I use the run keyword. The sleep is just so I can have enough time to gather logs. That's pretty much it. That's not the interesting part. Um, I'm going to tell you, I'm about to run this. Okay, so if I say CI run, and look at the status. I'm going to follow these logs, but the pipeline, the job hasn't started yet because I'm going to run GitLab Runner locally on my machine. I'm going to start two services. I'm going to start GitLab Runner, and then I'm going to start Step Runner right here on my laptop. When I start them, things are going to go kind of fast. So I want to kind of explain to you what you're looking at here first. So for starters, as I said, this is a Kubernetes. This is a Kubernetes job. I want this to run in Kubernetes. So for my laptop, I've got a cluster that I'm connected to. I'm going to watch it. I'm just going to kind of like watch to see what pods show up. It'll show you as they go through their phases, etc. Over here on the right-hand side, I've just got something tailing all the logs from Step Runner, the logs from GitLab Runner, finding pods, tailing their logs, just kind of making sure we can just see the trace across everything, just for the demo. All right, so I'm going to start these two services, GitLab Runner and Step Runner. Okay, so they started and it picked up that job already. So you can see it's running a gRPC step called Executor. You can see it's already created the container, which is running. Okay. And it's going to, this script will collect those logs too. It's done. It's done with our little sleep. You can see here's the job output. It ran this gRPC step executor. It ran my step, hello, and there's the output, and then it slept for a couple seconds. So it was my steps, but there's this other step on top. Um, so you can see here, this is the log from the pod. It's the job. It really actually went into the Kubernetes cluster. So it's a real thing working end to end. Let me show you what happened. Okay, I'm going to hide my terminal and I'm going to take you through a little code walk. So for starters, you saw the CI config. And I'm going to show you the runner config. Okay, this runner config is a little bit unusual. You'll notice here with the executor says step. So I made a new executor. It's kind of a fake executor. There's not much to it. And I made a new configuration called um, step. Sorry, step, whatever. And it points to this local resource. So this is a step reference. Step references can be local or they can be remote. So this could easily say like gitlab.com steps something something or executor something something at v1, etc. It doesn't really matter. I just brought everything here onto my laptop so I could work on it. So notice this step, Hello Kubernetes Executor step. This is a project that I created into my personal namespace. Okay. Um, I want to show you what that step looks like. This is that step. Okay. Now, this is kind of weird. Look at that. It's a gRPC plugin. So we got a couple weird things going on here. We have an executor that is a step. We have a gRPC plugin. Let me show you what actually happens. I intercepted this job in the multi command. So when runner starts up, it starts in multi.go because it runs multiple runners, right? Multiple runner entries. So each one of these has its own configuration, its own token, its own configuration. I grab it here. Like we get the job, right? We set up tracing and then I grab it right off the bat. And I'm returning that results, right? So I'm skipping all the config, all the building, the phases, like everything that GitLab Runner does for the most part. I'm skipping. Okay. And I'm running it here instead, process job with step. So the first thing that it does, process job with step, is it establishes a connection to step runner. And that's the other service that I started. So this is just running locally on my laptop on a socket. Um, it creates the step request. So that means it needs to take the job that it got and turn that into steps. And it involves a little bit of wrapping. So for starters, when I compile the steps, so the steps that you've seen in my configuration, those are like the CI model. Those are the YAML the user writes. We actually compile that into a proto to go over the wire. That's the first change that I made in this. Well, I made the executor, I made gRPC steps, I compiled it in GitLab Runner, okay, so that it'll be easier to manage this translation. I compile the user steps, right? So I get their stuff. Then I create my own sort of wrapper step, which is um, uh, which is just basically representing the job. So there's a couple things in here. There's the empty spec here. That's the interesting thing about this empty spec is this is what would be job inputs, right? So like if there's inputs to the job, I would put them here in this spec, and I would add the inputs to this proto payload. But we're not implementing job inputs this way right now. So basically, um, I take the configuration. Remember how I mentioned each runner has its own configuration? We grab the whole config exactly as it is, and we put it as an input. We give the image as an input, the list of services, right? We just grab the services um, that the user requested to run alongside that container. Um, and of course, the spec and the definition are the two, like the inputs in the body of the job that we compile. Okay, so then oh, here's a very key part. Okay. Remember that step that I pointed to that I wanted to be the executor, right? That is here, step config, right? Um, the actual step reference, which is called hello Kubernetes executor step. It just puts that reference there exactly as it found it in the config.toml, exactly like that. Okay. And it gives the inputs, which is some of those things that it pulled from the job and some of the things that it pulled from the config that is necessary to run this job. Okay, now it's up to this, it's up to this step. Okay, oh, that's a different step. I'm not going to show you that one yet. So what is this? What is a gRPC plugin? Well, for starters, um, it is not just going to exec a binary, right? Actually, this is a good example. You can see this is one way that steps run, you know, today is you can exec something or you can run a series of steps. This is a new way that you can get a sort of more advanced way to run a step that lets you have a full step service-like interface to interact with the step, including streaming logs, debugging, et cetera, et cetera. These two things here uniquely identify this plugin, the binary and the configuration. So the init here is that config, the runner config, right? So the pointing to this specific step and having that config uniquely identifies it. There in the implementation of gRPC steps, there's a plugin manager. So what this plugin manager does is first time it sees this gRPC step, if it doesn't have one running right now, it starts it and it passes in it, right? So here I have a chance to template the initialization of this plugin. So these two things here, the init and the plugin, are the key for deduplication of plugins. So if I have a second call to the same configuration of plugin, right? Same binary, same init, it'll just use the same one multiple times, right? So you don't like have an unbounded growing set of plugins. Just manage the lifecycle, and then when Step Runner shuts down, it can shut down all the plugins gracefully too. Okay. And then what it does is it actually, after it starts that plugin, like I mentioned, the plugin actually serves Step Runner interface. Okay, so it actually issues another run request to that step. That's the one that we manufactured before, right? Um, and here, actually, no, that's not true. This is really layered, so it's easy to lose my place, but it's done this way for a reason. Um, we template a run request, right? This allows us to sort of pluck out the pieces of information that we want, put it into a run request that we want to issue to the plugin. So this step lives alongside the actual plugin implementation. And that plugin implementation is here in this main. It's a Golang binary, right? So I'll get that same run request here templated. And what it's going to do is it's going to pull those same inputs out. Okay. All right. And it's going to execute my steps. Wait, where is it going to execute my steps? I haven't showed you where yet. Okay, so the first thing that it does is it collects all of my inputs. It creates the pod. Okay, so this is where this step specializes in Kubernetes. So it creates a pod, right? And that means that it actually takes the services and the job environment variables and it constructs the environment, right? Like there can be the user could request a specific memory size, etc. That all goes into constructing the correct size of a pod. Okay, waits for that pod to come up. And once that pod comes up, now it executes steps in that pod. What would normally happen is it would have an init container that injects step runner, just the way that we do like with the Docker executor. It'll put step runner inside. I short circuited it and I built one with step runner inside already, but I don't think that really matters. So now we have this pod, it's running step runner inside. So there's GitLab Runner, locally, step runner. I ran this gRPC step. It created this plugin. I called the plugin with my templated thing. It created the pod. The pod now has step runner inside. Now I'm connecting to the pod. The plugin is connecting to the pod. And it's going to create the client, which is going through the Kubernetes exec interface. So it's going to exec in there, sort of proxy in just the same way that the Docker does in order to connect to Step Runner, because that Step Runner inside the pod is doing exactly the same thing. It's serving on a local socket. Construct a request, put the variables in there. It's the same thing over and over again. And then finally, we're just going to use the Step Runner client, run and follow, and we'll follow the logs and run this thing. Okay. So one of the interesting things about these gRPC plugins is I could actually set it up to orchestrate it so that it could actually connect. It's serving all these APIs, right? It's serving follow logs, follow status. When we have a debug API, it'll serve that. I can connect those to the client as well. Like I can make it a lot more concurrent and allow the connection between each of these steps to bridge seamlessly into the Kubernetes cluster. But anyway, it runs, et cetera, et cetera. Okay, yeah, this is just about actually creating that client. Just machinations around Kubernetes exactly. Okay, so um, I showed you running that step, but there's something else that I added into the configuration here. You'll notice that there's this step which took over the role of Kubernetes executor, right? So we sort of I re-implemented the Kubernetes executor in here, but without any of the phases. The reason we don't need the phases is because we are going to be translating all of the existing jobs, phases and all, into a sequence of steps. So that user payload is actually going to get wrapped with the phases represented as steps. This doesn't care, it's just steps, right? Okay, so now notice there's this additional configuration that I put in here called runner policy, runner Kubernetes policy. So this is a configuration specifically to the Kubernetes type executors. And I gave it this thing called a pod filter step. Now, this is a step that is responsible for enforcing policy on pods. So there's this dilemma that we run into where users want to configure all kinds of things about Kubernetes and the environment and add things and do all this stuff that you can do in Kubernetes at the job level, but we also don't want users to do some things because they're too powerful. So the administrator, the runner administrator, wants to be able to constrain what the user can do in their job with the pod. So here is a mechanism for the administrator, right? This is the runner config. The administrator could add these policy steps in order, which can be any step that they want. They can use them and configure them to do something, for example, apply a JSON schema or like pick through the thing and force, don't use this image or override or add a container or whatever it is that they need to do to sort of like enforce. We may have a default policy that we add to the list that you can override. I don't know. The point is it's decoupled. Okay, that's the important part is it's decoupled. Um, so there's this other step here that I created. That's the one I was sort of showing you earlier. This is just a really simple exec, and it just has a pod spec input. It has a schema as an input, and it has a pod spec output. It's just a pod filter, right? And I did this pretty much just so that it would reject any pod that didn't satisfy the schema that I wrote for it. Um, and you can see here that you configure the schema. So I could take this same filter and I could give it my own schema, right? Um, Pointing to the local file resource. I could even put in an expression here and point to the schema that comes with this filter. So there's really nothing constraining you here. So to just to really drive home the whole pass-through nature of this, I want to show you the types that are used in the config. Um, Here, this is that policy in Go, right? And this right here, the Kubernetes policy settings map, is just a string anything map, right? So this configuration here just passes through as is. We've seen this before with the fleeting interface, right? The fleeting interface has a plugin config section, and this allows you to in your runner config have a section which addresses the specific plugin you selected and have that address the specific needs of that plugin without coupling with GitLab itself, right? So GitLab doesn't actually deserialize that and understand it. It just treats it as data and just passes it through. So this is just pass through. And of course you can put more than one. So, like this is a feature of the Kubernetes type runner. You know, we can choose to do this sort of thing with other types, etc. Since we're pulling all of this functionality out, I suspect that we could end up with another executor, which is just like, Docker and shell, right? It's like either you want to run this script, you want to run these steps here, or you want to run these steps in a container. The only difference is we wrap it in another step, right? So that's just a parameter. That would just be like the local executor. The other executor step we would want to have would be the one that runs things auto scale with task scaler and fleeting. And of course, that's what's known as that would replace the instance and the Docker autoscaler steps. It does the same thing. It just auto scales something, right? Once you get that connection back, uses SSH to bridge into it, just like we do with the Docker autoscaler now. Connects to step runner, runs the thing. It doesn't really matter if it's in a Docker container or not, right? Those are additional steps that you just wrap it with or not. Okay, so the point is, we've seen this before. This is like using all existing technologies, the path-through configuration, the plugins. It's the same framework, HashiCorp, Go plugins. It's just a lot more generic, right? And it's all based on the same steps interface. But why? Like, why do this? Like, what's the point? Um, First of all, it gives us more control over versioning the executors. Okay, so notice that this is the runner section, right? It has a token filtered out. It's its own thing, and it has its own step. So I could add a runner here, and I could upgrade the version of the Kubernetes step. I could have one runner on V1 and I could have one runner on V2. And what takes care of managing that sort of like multiples is the core gRPC mechanism of step runner, right? We're going to have gRPC steps for a lot of different reasons. A lot of the built-in steps are going to be based on gRPC, right? Like it's just another way of decoupling, like getting some distance, but also keeping that same gRPC contract. Um, yeah, so you get this versioning, right? And you can have anyone you want. The big point here, right? The point of fleeting, the point of steps, the point of using steps as executors is all about letting users, letting administrators, letting GitLab engineers solve their own problems in their own space. Right? Whatever you want to do, you should be able to do it. And we support a specific set of things, but you can add on to that or you can extend that. Having those seamless extension points like fleeting, right? We have 3 plugins we support for the major cloud providers, but you can write your own, and people have. And it's a very powerful way to allow them to get the maximum benefit from the core of GitLab Runner, but for whatever environment they have, right? That adaptability. And the same thing goes here. So now actually right here um in the configuration, I can bring my own executor. So this is also a replacement to the custom executor, right? If you look at it right, it's the custom executor just through a gRPC interface, which happens to be steps, right? So this brings everything together, all the different executors on one interface. So now my custom executor also can support steps natively, right? My custom executor can support um, all the same log streaming, dynamic, secrets, masking, etc., right? Because it's all steps native. Um, I mentioned debugging earlier, right? One of the challenging things about CI is you can't get in there. When it's local, I could just, get my hands on it. But once it's in CI, if there's something unique in CI, like the token, specific permissions of the token, I had dealt with this the other day. It was a huge pain. Uh, it would only fail in CI because of the permissions of the job token. It's hard to get in there. So we're going to add a debug API to the gRPC interface so that you can connect and you can add breakpoints to anywhere in the execution tree, right? And you can step, and that breakpoint and stepping context can bridge gRPC calls, right? Each participating server sends that information forward. So I could connect to the executor and I could step into the job environment and I could step into the container, or I could step into the pod and I could step through the individual things that happen inside the pod. So all the way from all the way from pretty much the job response, I can trace and follow through the execution of exactly how the environment was set up, exactly how it was used, what happened inside of it. Um, and like it's not very far to jump into a REPL at that point, like you could just drop into a REPL, type something in, play with it, see what's there, right? Like the whole point is to let you access the job environment and the job as with the full set of developer tools. Of course, we're not going to let end users connect to the debug API on the manager, right? That would give you root. But we would allow them to connect to the debug API on their jobs. So you can jump in at any point in this chain. Um, so additionally, one of the benefits of unpacking the built-in executors into steps is it lets us kind of tackle the versioning, or sorry, not the versioning, the configuration problem of steps, or sorry, of runner iteratively. So right now, Runner has a huge configuration service. It's got like all the different things for all the executors, and about half of it is all the things for all of Kubernetes, right? Like it's this big configuration. And it's really hard because there's not really good validation. And it's hard to do this thing that, to help with Kubernetes because it doesn't answer some of the questions about VMs, and it's hard over here, but it's difficult to unpack it. We haven't made a lot of progress here. But as you could see, when it comes to configuration, when we can address the executor specifically, we can give it configuration and we can externalize configuration. So I could, if for example, maybe we decide what we really need for Kubernetes executor is JavaScript, right? Maybe we want to write JavaScript because we just need a full-blown language to enforce the policy we want. You can come up with your own either JavaScript or DSL or whatever configuration works for the Kubernetes problem space, right? Make a file, right? Make that configuration. You don't have to embed it in the toml. You could, right? Like if it's convenient, we could put it in the toml and pass it through, or you could put it in its own file and you could just point to it, like this JSON schema here. Um, so yeah, mostly this is about getting a little bit of decoupling and latitude, escape hatches, and uniformity through the whole job execution lifecycle. So the proposal here is we know that we want plugins for executors, right? We want that escape hatch. We want more control, um, but we also have plugins for steps. And we're going to have to manage the lifecycle for this. Let's make it the same thing. So we use the same mechanism. Okay. Um, yeah. So that's what makes this so exciting to me is like this is the next big chunk of unpacking. Like you'll notice that I didn't have to deal with the abstract shell or the sort of binding of the config. Because what happens inside GitLab Runner right now is you make a build, and which is sort of the combination of the job response and the config into this build object, and you call it with this multiple phases. Like it's gotten really twisted and weird, right? We could just set that aside and just represent everything as steps. Um, so then what next? So the epic that I've sort of set up and that we're starting to get into now is seamlessly taking all of the jobs everyone's running now that are scripts, translating those into steps. Okay, so it's got to be backwards compatible. So we're going to take like a script that you've written as it is. Users don't have to change their job. Take the script that you've written. We're going to put it as an input to a special backwards compatible script step. Take all the job and variables, export them as environment variables, just like you used to, and we're going to pass that over gRPC. So we're going to take the script, the services, Docker setup if you need it, all the phases, artifacts, everything. We're just going to compile it all into this list of steps. I'm going to send that over the gRPC. So that's the sort of piece that we're embarking on the back end, right? To sort of transform the steps, transform runner into using across the board the steps execution model, which gives us that nice gRPC interface for reconnection, for streaming, etc. This is separate from the steps product, right? You'll notice that I have my run keyword there. That was me explicitly saying, here's my steps, right? But we're going to translate those in the back. Um, the next thing is once you have that payload, right? If you're translating or if you make them explicitly, then we get to this demo today, right? Right now, all I have is steps. All I need to do is create an environment. It doesn't have to be this complicated. We don't have to hard code phases in the config build object, right? Here's the config that I know about. Here's the job that, here's the steps, right? That's it. So, um, yeah, I think that this is worth kind of experimenting with because we can build it alongside what we have now. Like you could just take what I did here, make this other executor, and if you say, right, executor step, then you get this, right? It can be a beta thing that lives alongside the built-in executors. So that's where I want to start. Maybe I have someone who's interested in like experimenting with this to unlock some of the use cases around the custom executor, um, building a better version of it. So they can start on this now. It's fine to start experimenting with it. At some point, right, when we're like, wow, we have these steps that do what the Kubernetes executor is, how do we migrate? You can, when someone says step executor equals Kubernetes, right? You can just translate that into the step. You see, like you could just sort of do this little part for them. So we have a way to seamlessly also migrate existing runner configuration to the steps model as well. So we have a way to migrate users' jobs to a steps execution model. We have a way to migrate runner configuration seamlessly to steps execution. And then it becomes just a thin wrapper. Like you could see here in multi, like, it's just that. And at that point, GitLab could just build that step and push it, right? Like you could choose to do this in a different way, or it could push just the steps to, another entity that distributes the work, right? Unlocks a lot of things. So this is the sort of a preview of what I think will be the next big thing in our evolution of GitLab Runner into a decoupled, decomposed, do-it-yourself kind of execution model. So thanks for watching this. Um, I'm going to push the code so you can take a look at it. I'm going to make a blueprint to represent this so we can talk about it and review it. Like, not everything, we don't have to do things exactly the way that I've showed here, but the idea I think is pretty powerful. So I'll have a blueprint of some code and there's this video. So yeah, thanks a lot for watching. And yeah, pretty excited about this. Bye.